Are you also struggling in solving the series and parallel combination of resistors? So dear class 10 students, you are at the right place. So today we are going to cover the derivation of series and parallel combination, each and every detail we are going to cover. So let us start. Today we will cover the series and parallel combination of resistors, right? So first of all, we will cover the series combination and then parallel combination. And in understanding the series and parallel combination, one very important point is the very interesting and important Ohm's law. Hope you all know very well about Ohm's law, right? What is Ohm's law? In general form, we say that Ohm's law is V is equal to IR. Right, where V is the potential difference. Right, I is the current and R is the constant which is resistance. So here I am giving you just an overview that what is Ohm's law, because you should have a very nice knowledge of Ohm's law before understanding and going to the topic of series and parallel combination of resistor, because this Ohm's law is totally based on the resistance, right? What actually happens is, in Ohm's law we say that at constant temperature, potential difference across any circuit is directly proportional to the current flowing through it. Here it is, Ohm's law is at constant temperature. What does Ohm's law say? That at constant temperature, the potential difference across any circuit is directly proportional to current flowing in the circuit. मतलब कि पोटेंशियल डिफरेंस किसी सेल का उतना होगा जितना ज्यादा उसमें करंट फ्लो कर रहा होगा. अब आता है इस प्रोपोर्शनैलिटी को हम हटाते हैं कांस्टेंट से, प्रोपोर्शनैलिटी कांस्टेंट से, राइट? एंड वी गेट दैट V is equal to proportional constant is substituted from the constant R, I. The R is actually resistance. So at constant temperature, जब टेम्परेचर हमने कांस्टेंट रखा है तो किसी सर्किट में जितना उस सर्किट या वायर या अप्लायंस का जो भी उस सर्किट में यूज हो रहा है जिसका जितना रेजिस्टेंस होगा, राइट? अब अगर रेजिस्टेंस बढ़ता चले रेजिस्टेंस जितना होगा उस पर डिपेंड करेगा कि कितना पोटेंशियल डिफरेंस है एंड कितना करंट फ्लो हो रहा है. सपोज दैट V is equal to RI is Ohm's law, राइट? तो क्या होगा, जैसे जैसे हमारा रेजिस्टेंस इंक्रीज होगा तो करंट अल्टीमेटली कम होता जाएगा, बिकॉज पोटेंशियल विल रिमेन सेम. हमने अगर 4 वोल्ट की बैटरी यूज करी है तो वो 4 वोल्ट ही रहेगी. तो रेजिस्टेंस के इंक्रीज होने से क्या होगा, मतलब रेजिस्टेंस के इंक्रीज होने से क्या हुआ, उसने करंट अपनी तरफ खींचा, मतलब कि उसने करंट फ्लो में एक ऑब्स्टैकल जनरेट किया, राइट? तो उस ऑब्स्टैकल की वजह से, मतलब जितना ज्यादा बड़ा ऑब्स्टैकल होगा, रेजिस्टेंस जितना ज्यादा होगा, रेजिस्टेंस इज बेसिकली एन ऑब्स्टैकल इन द फ्लो ऑफ करंट. तो रेजिस्टेंस जैसे जैसे बढ़ता जाएगा वैसे वैसे करंट फ्लो कम होता जाएगा, राइट? व्हाई? बिकॉज द पोटेंशियल difference will remain same across the whole circuit, right? So this is about the Ohm's law. Now by using this very important Ohm's law, that is V is equal to RI, we are going to learn about the series and parallel combination of resistors. Now suppose that in any circuit you are using a resistance. First of all, you are using a resistance of just and here it is a battery, it is connected to battery of V volt. Now the current starts flowing through it, right? Now the current is flowing and suppose the resistance is actually very large, suppose it is of 100 ohm, right? Now the current will flow. Now how much current will flow through this? We will calculate. और suppose volt मतलब पोटेंशियल डिफरेंस कितना है, सपोज दैट 20 वोल्ट है, तो अब हम इस रेजिस्टेंस में करंट कितना जा रहा है, राइट। इस रेजिस्टेंस में कितना करंट जा रहा है वो हम कैसे कैलकुलेट करेंगे? थ्रू ओम्स लॉ। वी विल अप्लाई ओम्स लॉ, राइट। ये हमारा सर्किट है, अब हम अप्लाई कर रहे हैं ओम्स लॉ, तो V इज इक्वल टू आई आर। So what will happen? 20 volt is potential difference. Current we have to find out, and here is the resistance of 100 ohm. तो अब देखिए जितना ज्यादा रेजिस्टेंस होगा उतनी कम करंट की वैल्यू आएगी थ्रू द सर्किट, बिकॉज द पोटेंशियल विल रिमेन कांस्टेंट, पोटेंशियल डिफरेंस विल रिमेन कांस्टेंट. So now if we will calculate, I will be 20 divided by 100. That will be 0.2 ampere. So it means as the resistance was very high, right? तो करंट कितना हमारे सर्किट में फ्लो हो पाया? हमें तो करंट फ्लो कराना था, हमारा मोटिव करंट फ्लो कराना था, बट रास्ते में रेजिस्टेंस इतना ज्यादा आ गया कि करंट फ्लो 20 वोल्ट की बैटरी लगाने पर भी सिर्फ 0.2 ओम हमें ऑब्टेन हो पाया थ्रू आउट द सर्किट, राइट। अब जैसे जैसे हम इसकी रेजिस्टेंस की वैल्यू कम करते जाएंगे, सपोज अब ये 100 ओम की जगह सिर्फ 10 ओम का रेजिस्टेंस है इस अप्लायंस में, तो अब क्या होगा? ये 10 ओम. नाउ व्हाट विल हैपन? दिस विल बी ओनली 10 ओम. अब हमारे पास पूरा 2 ओम का करंट आ गया. देखा आपने? For the same potential difference, as we reduced the resistance, the value of current increases. This is what we actually conclude from Ohm's law, that as the resistance in the circuit increases, the current obtained will decrease because the potential will remain constant. Right? The potential difference will remain constant. So this is all about the Ohm's law. I have given you an overview of Ohm's law and how to apply it. What is the significance of Ohm's law? Now we will move forward and look what is series and parallel combination of resistance, right? And after that, at last, we are actually going to solve some very important numericals. So watch this video till the end. What I have told you in this lecture about the Ohm's law, right? So now let's go to series and parallel combination of resistors. So now, without wasting our much time, let us start the series and parallel combination of resistance. So first of all, we will understand the series combination of resistance. Now what is series combination? As the name signifies, the resistances in this circuit, in the series circuit, are connected next to each other. Suppose this is one resistance, then if we have to connect another resistance, we will connect in series, means just next to it, right? So this is our series circuit, and I have connected it to a battery or cell of potential difference V, right? This is the voltage, potential difference V. This is resistance R1, resistance R2 and resistance R3, right? So what is potential difference? As you must be knowing that this is the positive terminal, this is the negative terminal just by the convention, and current will flow from positive terminal to negative terminal. This is the direction of flow of current. So what will happen? The potential difference is V. The voltage of this battery is V. It means that positive terminal, the potential differences means the highest potential will be V and the lowest potential will be 0. That is why their potential difference is V, that is V minus 0. Higher potential minus lower potential, that is V minus 0, giving it the potential of V volt. Now what will happen? The current, suppose that current I is flowing through this circuit. Now what will happen? In the series circuit, you have to remember that in the series circuit you have to remember some of the very basic things, that is the current is same throughout. Current is denoted by I, it is same. Current will flow, the amount of current will flow in the same amount through all the resistances. That is in R1 also the current I will flow. In R1 also the current I will flow, in R2 also current I will flow, and in R3 also current I will flow. That means the current through each resistance will be same. This is the significance of series combination. In series combination, the current through each resistance will be same. Now, but the potential will be different. If you will apply a voltmeter here or here or here, it will give you some other reading, it will give you some other reading, and it will give you some other reading. So the potential difference across R1 resistance will be V1, R2 resistance will be V2, and R3 resistance will be V3. Means the potential difference will be different. Why? Because what is potential? Potential is actually the, in a way we can say that potential is the pressure difference of current, right, of electrons, pressure difference of electrons. So if resistance is there, it means this resistance, for this resistance you can apply Ohm's law. Now what we will do, we will apply Ohm's law across each resistance to find out the potential. So applying Ohm's law. Applying Ohm's law across R1. जब हम R1 के across potential Ohm's law apply करेंगे तो क्या होगा? What is Ohm's law? V is equal to I R. तो अब हम इसको सबसे पहले R1 के across apply करेंगे. तो R1 के across potential difference कितना है? V1. तो V1 is equal to I is same and R1. V2 के across, R2 के across हम Ohm's law apply करेंगे तो V2 is equal to I R2. V3 is equal to I R3. Now, do you agree that this V1, V2 and V3, their sum will be equal to the main cell potential difference, right? कहीं और से तो potential नहीं आ रहा है ना? The potential will remain equal to the potential difference of the cell only. So it means that V1 plus V2 plus V3, that means our V equivalent, that is the potential difference of the cell, will be equal to V1 across the resistance R1, V2 across the resistance R2, and V3 across resistance R3. Right? So here it is. And one more thing, that if, let us suppose that, let equivalent resistance is R equivalent and the current flowing through the circuit is I. So if we apply Ohm's law for the whole circuit, means for the equivalent resistance, for the current I and for the potential difference V. So applying Ohm's law for the whole circuit, what we will get? We will get V is equal to I R equivalent. R is the equivalent resistance, right? This potential difference is across the whole circuit, and the resistance of the whole circuit we have supposed it to be R equivalent, and the current flowing is the same, that is I only, right? So now substituting the values, if we put V is equal to V1 plus V2 plus V3, right? Now I will take some of these important equations, right? So from the previous slide, we have obtained V1 is equal to I R1, V2 is equal to I R2, V3 is equal to I R3, right? And we have also concluded that V is equal to this. Let me draw the circuit, right? This is our potential cell. Current I is flowing through it, right? This is R1, R2 and R3. Now across this the potential difference is V1, V2 and V3. right? So we have got V is equal to V1 plus V2 plus V3, and we have also concluded that V equivalent means V. For the whole resistance, when we applied Ohm's law for the whole resistance, we got V is equal to I R equivalent. R equivalent is the equivalent resistance that we have supposed for the whole circuit. Now, if we substitute the values in this equation from all these equations, for example, we have got V is equal to, in this equation I am going to substitute the values now. What I am going to do is, I am putting the value of V as V1 plus V2 plus V3. V1 plus V2 plus V3 is equal to, we have I R equivalent, right? I R equivalent. Now the values of V1, the value of V1 is, from the Ohm's law, we have got V is equal to I R1 and V2 is equal to I R2. V3 is equal to I R3 is equal to I R equivalent, right? Now, taking I common, R1 plus R2 plus R3 is equal to I R equivalent, right? What I have done? Taking I common. Now this I and I will be cancelled, and we have our final R equivalent resistance for the series combination. Here we are with our final derivation and final formula of R equivalent, that is R1 plus R2 plus R3. It does not matter how many resistance you keep on connecting in series, the formula for the series combination equivalent resistance is R1 plus R2 plus R3 and so on, means it is just a simple algebraic addition, right? So this is the derivation for the series combination. Hope you all have understood it well, right? So what are the main points in series combination? First is, the current is same across each resistance, right? The potential difference will be distributed. Why it will be distributed? Because the overall potential will remain same as that of the cell, right? So it gets distributed across each resistance, right? And also you can understand it through the Ohm's law, because this is a resistance, so it will take some different amount of potential as well as it is taking the same amount of current in the series resistance, so it will take some different amount of potential. Similarly, each resistance will take different amount of potential, because in series the current is same across this, and in order to satisfy, you can say, the Ohm's law, that is V is equal to IR, the potential difference will be different across each resistance. And we have our final equivalent resistance for series combination, that is R equivalent is equal to R1 plus R2 and R3, right? So hope you all have understood. Now we will see the derivation. Now some of the important points for series combination is that in series combination, the equivalent resistance is always greater than all the individual resistances connected in series. Means if the individual resistances are, suppose that 1 ohm, 9 ohm and 100 ohm. So the equivalent resistance will be 1. Now see, the greatest resistance for the among the individual resistances is the 100 ohm, but equivalent resistance will be 110 ohm. That is even greater than the greatest resistance of the individual resistors, right? So this I want to tell you that in series, it is actually a very important point and asked in exams so many times, that It seems very simple, but when it is compared, when you will study the parallel combination, you will learn something different. It is not the conclusion in the parallel combination. That is why this point is important, that in series combination, no matter what, but the equivalent resistance that we obtained is always greater than the individual resistors that are connected in series. Now, second point that is very important is we can't use series combination in our domestic circuit, because in series combination we saw that current is same across each resistor. That means and what are these resistance actually? These resistances are nothing but only these electrical devices like geyser, iron, right? Geyser, iron, fan, tube light, LED bulbs, TV, whatever. All the electrical appliances that we use at our home are a sort of resistors, right? These all provide resistances. So each device needs different amount of current. So if we connect all our appliances through the series combination, the same current will flow, and this is not suitable. Maybe that amount of current is suitable for one device but not for the other. This is the reason. And also one main problem of the series combination is that if any one of the device or resistor break or fuse, the whole circuit is going to be damaged. The whole circuit will be of no use, even if in the very big series combination circuit, even if a single device or appliance is going to be broken down or fused, right? So this is the thing, and each device require different amount of current, but in series combination all the devices get same amount of current. That is why we cannot use series combination in domestic circuit or any other commercial use. These are some of the disadvantages of series combination, right? And this one point, that R equivalent is always greater than the individual resistor, is actually very important. Now let us move to the parallel combination. So now let us start learning the parallel combination of resistances, right? So now our next goal for today is the parallel combination. I will derive you the formula of parallel combination. Now what happens in parallel combination? First of all, let me draw a circuit for you, right? Now what happens in parallel combination? In parallel combination, the different individual resistances are connected by a common point, right? See what is happening? These are connected by means all the individual resistance are connected between two common points. It means this suggests that the potential difference across each resistance is going to remain same across all the individual resistances. I have connected it through a battery of V volt again. This is the resistance R1, R2 and R3, right? Current I is flowing through it. Now in this parallel combination, what are the conditions, or you can say points, that in parallel combination as C? How will you say that the potential is same across all the resistances? Actually what is happening, this resistance R1, R2 and R3, you can see all these three are connected between the two common points, right? Let's say these points are A and B for a moment. Now what is happening, if you will see this circuit from here, from the battery, you can see that the potential difference here across this is V. Means in the positive, the higher potential here will be V only, right? This wire provide no resistance, so the potential will remain same. This is V, and here see, I have told you already earlier in the series combination that how this potential V came, because the higher potential is at V volt and the lower potential is at 0 volt. That is why the potential difference is higher potential minus lower potential. it came out to be V volt. It means higher potential is at V volt and lower potential is at 0 volt. So see, all the three resistances are between the same potential difference, right? That is V and 0. That is the potential difference across each potential is V minus 0, that is V volt. So potential difference in parallel combination is same across potential difference remains same, right? And current distributes in it. Now again, this is to justify the Ohm's law, you can say. Now what will happen? This is R1 having the potential of V volt. This is R2 having the potential of V volt. This is R3 having the potential of V volt. Now in order to justify the Ohm's law, that is V is equal to I R, the current will be distributed over here. That is, in all these branches, the current is different. Right? The current is different because in all these branches, the current is going to be distributed. To justify Ohm's law. मतलब जब मैं कह रही हूँ to justify Ohm's law, सीरीज में क्या हो रहा था कि रेजिस्टेंस में करंट सेम जा रहा था, तो पोटेंशियल डिस्ट्रीब्यूट हो रहा था in order to justify or satisfy the Ohm's law. Ohm's law क्या है कि पोटेंशियल मतलब V is directly proportional to current, V is equal to IR वाली कंडीशन सेटिस्फाई होनी चाहिए. So that is why इसमें करंट डिफरेंट रहेगा. अब देखिए, अगर V सेम ही है, R1 चेंज हो रहा है, तो इसका मतलब अब R को चेंज होना होगा. अगर R1 है तो I को I1 होना पड़ेगा, कुछ और होना पड़ेगा, क्योंकि पोटेंशियल इस केस में सेम है. तो ये चल रहा है हमारा इसके केस में, पैरेलल के केस में, राइट. I2 अब R2 के अक्रॉस भी पोटेंशियल डिफरेंस भी ही है, तो अब I को I2 होना पड़ेगा, मतलब करंट विल बी अ डिफरेंट. अब अगर R3 रेजिस्टेंस के अक्रॉस भी पोटेंशियल डिफरेंस भी है, तो ओम्स लॉ सेटिस्फाई होने के लिए इस करंट को फिर से चेंज होना पड़ेगा. दैट इज व्हाई द करंट इज गेटिंग चेंज्ड इन ऑल द थ्री ब्रांचेस. दैट इज इन R1 द करंट I1 will go, in R2 the current I2 will go, and in R3 the current I3 will go. Why? Because the potential difference is same across each resistor and the resistance is getting changed. So in order to satisfy the Ohm's law, the current will get distributed, and this same was the case in case of series combination. But there what was happening, that current was same across each resistor but the potential was changing. अब उसके केस में क्या हो रहा था, सीरीज के केस में क्या हो रहा था कि हमारा करंट सेम था, तो अगर R1 के अक्रॉस करंट I जा रहा था तो V को चेंज होना पड़ता, क्योंकि ये वैल्यू कांस्टेंट रहनी है. अब मतलब ये RHS LHS को इक्वल रखना है, इसलिए सेटिस्फैक्शन का मतलब ये है यहाँ पे मेरा कहने का, राइट. अब अगर R2 के अक्रॉस जा रहा है बट करंट स्टिल I इज फ्लोइंग इन, अभी मैं सीरीज कॉम्बिनेशन की बात कर रही हूँ, करंट सेम था अक्रॉस ईच रेजिस्टर, रिमेंबर. तो अब पोटेंशियल को V2 होना पड़ेगा. अब अगर R3 जा रहा है, R3 में भी करंट I जा रहा है, तो पोटेंशियल को V होना पड़ेगा. सो दिस इज व्हाट आई वांट टू से, that now have you understood that why the potential gets distributed in case of series combination and why current gets distributed in case of parallel combination. In parallel combination, the potential remains same across each resistor because all the resistors are connected between the two common points, this results in having them the same potential difference. So if the potential difference is same and resistances are different, it means to satisfy the Ohm's law, currents need to be distributed in all the branches or across all the resistors, right? So now applying Ohm's law across each resistor. Again we are doing the same thing, applying Ohm's law across R1. So what will happen? In this case, we will apply Ohm's law in a bit different way because here current is getting changed, right? So what we will do? V is equal to I R. I is equal to V by R. We will apply this because in this current is getting changed. So across R1, what will happen? I1, right? across R1, I1 current is flowing. So I1 is equal to V upon R1. I2 is equal to V upon R2. I3 is equal to V upon R3. Now, this is across each resistor. Now what will happen? What will be the, let's suppose, the equivalent current flowing is. Equivalent resistance be R equivalent again. So applying Ohm's law there, and let the total current that was flowing was I, right? So for the whole circuit, the current flowing was I, equivalent resistance is R equivalent, and potential is V volt, right? So what will happen now? Applying the Ohm's law again, I is equal to V by R equivalent, right? Right, equivalent, because different currents are flowing, so we have taken equivalent current across whole resistor to be I equivalent, right? And what will be the equivalent current in general according to these three currents? I equivalent will be I1 plus I2 plus I3, right? So we have got our one equation this. For I equivalent, that is I1 plus I2 plus I3. And here we have I equivalent from the Ohm's law, that is V by R equivalent. Now substituting the values of I in this equation. In this equation I am going to substitute the values. Now what is I equivalent? I equivalent is V by R equivalent. Right, and what is I1? I1 is equal to V by R1. I2, what is I2? I2 is V by R2. And what is I3? I3 is V by R3. Now again, in the next step we will take V common in the RHS. R equivalent is equal to, we have taken V common, it will be 1 upon R1 plus 1 upon R2 plus 1 upon R3. So again we have, after cancelling this voltage, that is V, we have reached our final derivation of equivalent resistance for parallel combination. That is 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. This is our final derivation. Now again, no matter what, how many resistors are connected like this in parallel, even if it is infinite, the equivalent resistance for parallel combination will be 1 upon R equivalent is equal to 1 upon R1 R plus R2 plus 1 upon R2 plus 1 upon R3 and so on, right? So this is all about the parallel combination. Hope you all have understood. Now here you can see. Let me take an example, right? For that same point that we learned at last in the series combination, let's suppose that R1 is equal to 5 ohm, R2 is equal to 10 ohm. Let these two resistors are connected in parallel. So now I need to find the R equivalent. What I will do, I will apply the formula. 1 upon R equivalent is equal to 1 upon 5, that is R1 plus 1 upon 10, that is R2. Now what will happen? Its LCM will be 10, right? 2 plus 1, that is 3. Equivalent resistance, that is C. Now 1 upon R equivalent is 3 by 10. So it means that now R equivalent is 10 by 3, right? That means it came out to be 3.3 and so on, right? So did you saw The equivalent resistance in case of parallel combination is even smaller than the individual smallest resistance that was connected in parallel. But in case of series combination, we saw that it was vice versa. Means the equivalent resistance came out to be even greater than the largest resistance that was connected in series. But that is not the case in parallel combination. So these are the important points that are actually even very frequently asked in exams, that about the equivalent resistance in parallel combination and series combination. It is greater in case of series combination and even smaller than the smallest individual resistor connected in parallel combination. So these are the cases. Now actually the parallel combination is used very frequently in our domestic circuit. Frequently not. Actually it is the circuit that is used in our domestic circuits. Why? Because in this, each resistor will take current according to its requirement. See, the current is getting distributed, means all the appliances can get the current according to their own requirement, right? That is why it is used in parallel combination, and it is also actually very safe, right? In this, what will happen, even if any one circuit will break, it will not affect the whole circuit. All the other devices will keep on working. So these are some of the advantages of parallel combination over series combination. So hope you all have understood well about the derivation, about all the confusions. I think I have cleared that when the current and why the current is getting distributed in parallel combination and why potential gets distributed in series combination to justify the Ohm's law. Did you saw the significance of Ohm's law, right? And did you understood the parallel combination and series combination? Now don't get confused about those small points, that when current is same and when potential is same, right? Try to understand, go through these derivation once again, and in the next lecture we are going to solve some of the very important previous year questions and some very important and tricky questions that seems tricky to you about the combination, about the mixed combination of parallel and series combination. Right, till then, keep studying, take care, bye bye, and thanks for visiting Chariot Tutorials, where knowledge leads the way. Bye bye.